Right now, at this exact moment, something invisible is pulling on you. Not just the ground beneath your feet, but the entire universe. Every star, every planet, every galaxy is exerting a tiny gravitational pull on your body right now. An endless web of invisible connections stretching across space. But here's the strange part. Gravity never seems to stop. It never runs out of energy, never weakens to zero, and never switches off. It has been working continuously for nearly 14 billion years. Think about that. The same force that makes an apple fall from a tree also keeps the moon orbiting Earth. It holds planets around stars, binds galaxies together, and even bends light across the cosmos. Gravity is everywhere, and yet we still don't fully understand why it never turns off. So what exactly is gravity? Is it really a force? Or something deeper built into the fabric of the universe itself? And why does this invisible influence connect everything, from atoms to galaxies, across unimaginable distances? In this video, we're going to take a journey across the universe to find out, from the smallest particles of matter, to planets, stars, and the largest structures in existence. And along the way, you may discover something astonishing. You are not just living in the universe. You are part of an invisible cosmic web that has never stopped pulling things together since the beginning of time. Out there in the vast darkness of space, something strange is always happening. Every object in the universe is pulling on every other object. Not occasionally, not sometimes, but constantly. An invisible connection stretching across unimaginable distances. A tiny pebble on Earth pulls on the moon. The moon pulls on the Earth pulls on the sun, and the sun pulls back. Even distant stars and other galaxies exert a faint gravitational tug on you right now. And yet, here's the mystery that quietly sits behind all of this. Gravity never seems to stop. It never runs out of energy, never fades away to nothing, never takes a break. It simply continues, everywhere, forever. Think about that for a moment. A ball thrown into the air eventually falls because gravity keeps pulling it downward. The moon keeps circling Earth because gravity never stops guiding its path. But what keeps gravity itself active in the first place? Where does this endless influence come from? Why does the universe seem permanently connected by this invisible pull? Why doesn't gravity simply switch off one day, like a machine running out of fuel? To begin unraveling that mystery, we first need to see just how everywhere gravity truly is. If someone could zoom out far enough to watch the universe like a grand cosmic ballet, one pattern would appear everywhere. Nothing is standing still. Planets circle stars, moons orbit planets, and entire galaxies slowly rotate through space. Behind all this motion, gravity is quietly orchestrating the dance. On Earth, gravity feels ordinary. It's the reason an apple falls from a tree, or why a dropped glass hits the floor. But the same invisible pull that guides falling objects here is also controlling the movement of worlds millions of kilometers away. The force that drops a pebble is the same force that holds entire solar systems together. Look at the moon drifting across the night sky. It doesn't fly away into space because Earth's gravity keeps it gently tethered. At the same time, the moon pulls back on Earth, lifting our oceans into tides. Two massive bodies locked in a silent gravitational conversation. Travel even farther outward, and gravity's reach becomes even more dramatic. In distant parts of the universe, gigantic black holes bend light itself, warping the paths of stars and gas clouds around them. Galaxies collide, merge, and reshape each other under gravity's relentless influence. From the smallest falling stone to the motion of galaxies billions of light years away, gravity never seems to pause. It's constantly shaping movement across the cosmos. But the deeper mystery begins when scientists zoom in to the smallest scales of nature, because down there, gravity behaves very differently than we might expect. Now, imagine shrinking down, far smaller than a grain of sand, smaller than a cell, smaller than a molecule, even smaller than an atom. At this microscopic scale, the universe begins to look very different. Particles flicker, collide, and interact through powerful fundamental forces. Here, gravity almost seems to disappear. Compared to other forces of nature, it's unbelievably weak. Electromagnetism, for instance, can easily overpower gravity between tiny particles. A simple refrigerator magnet can defeat the gravitational pull of the entire planet. To picture this, imagine two tiny dust grains floating in space. Gravity does pull them toward each other, but extremely slowly. Meanwhile, A tiny electric charge between them would create a force millions of times stronger. In the microscopic world, gravity is practically whispering, and yet something fascinating happens. Even though gravity is incredibly weak, it never vanishes completely. Every particle with mass, every proton, neutron, and atom still contributes its own tiny gravitational pull. It's as if each particle adds a nearly invisible thread to a massive cosmic web. Individually, those threads are almost meaningless, but when trillions upon trillions of particles gather together, their combined pull becomes enormous. This quiet accumulation is what eventually shapes planets, stars, and galaxies. To see how that happens, we need to zoom back out, to the scale of entire worlds. Now let's zoom back out, from particles and atoms to entire worlds. At the scale of planets and moons, gravity suddenly becomes impossible to ignore. It's the quiet architect that shapes spherical planets and holds entire worlds together. Without gravity constantly pulling inward, planets simply wouldn't exist. Imagine trying to build a planet out of loose rocks floating in space. At first, each rock drifts quietly through the darkness, but slowly gravity begins pulling them toward one another. Like snowflakes gathering into a snowball, matter begins to clump together. As more material gathers, the gravitational pull grows stronger. Soon, enormous masses of rock and metal collapse into a roughly spherical shape. Gravity smooths out mountains, pulls matter toward the center, and forms a stable planet. It's the same reason soap bubbles become round. Nature prefers balance. Gravity also decides whether a planet can hold on to an atmosphere. If the gravitational pull is strong enough, gases remain trapped around the world. That's why Earth has a thick atmosphere, while smaller worlds, like the Moon, lost theirs long ago. Gravity acts like an invisible cage holding air, oceans, and clouds in place. And it doesn't stop there. Gravity keeps moons orbiting planets and planets orbiting stars in delicate cosmic loops. Our moon circles Earth every month because gravity never stops pulling it inward. But once scientists learned to understand these motions, they discovered something remarkable. They could actually use gravity itself to travel through space. Once scientists began to truly understand gravity, something remarkable happened. What once seemed like a mysterious force became a powerful tool for exploration. Instead of fighting gravity, engineers learned to work with it, and suddenly gravity became one of humanity's greatest allies in space travel. When a spacecraft leaves Earth, it doesn't simply fly straight through space. It enters a carefully calculated orbit shaped entirely by gravity. Just like the moon circling Earth, satellites fall endlessly around the planet. They're constantly falling, yet always missing the ground. Space agencies also use an extraordinary trick known as a gravitational slingshot. A spacecraft flies close to a massive planet like Jupiter or Saturn. The planet's gravity grabs the spacecraft and flings it forward at incredible speed. It's a bit like a skateboarder grabbing a moving train and being pulled faster. This technique has allowed spacecraft to reach the farthest edges of our solar system. Missions like the legendary Voyager probes used planetary gravity to accelerate across billions of kilometers. Instead of carrying massive amounts of fuel, they borrowed energy from moving planets. Gravity, once again, doing the invisible work. Even here on Earth, gravity affects technologies we use every single day. The GPS in your phone must account for tiny shifts in gravity predicted by Einstein's theory of relativity. Without those corrections, navigation systems would quickly drift off course. But to understand why gravity behaves this way everywhere in the universe, we need to look at the deeper physics behind it. For centuries, scientists believed gravity worked like an invisible rope. One object simply pulled on another across empty space. That was the picture first described by Isaac Newton, and it explained planetary motion surprisingly well. But deep down, something about that idea always felt incomplete. Then, in the early 20th century, a new perspective emerged from the mind of Albert Einstein. Instead of thinking about gravity as a pulling force, Einstein imagined something far stranger. Space and time themselves could bend and stretch. Gravity, he realized, might actually be the shape of the universe itself. Picture a stretched rubber sheet. If you place a heavy bowling ball in the center, the surface curves inward. Now, roll a marble across that sheet. The marble doesn't get pulled by the ball, it simply follows the curved surface. This is essentially how gravity works in Einstein's theory. Massive objects like planets and stars bend the fabric of space-time around them. Other objects move along those curves, creating what we experience as gravity. Nothing is pulling them directly. They're simply following the shape of space. And that explains something profound. Gravity doesn't run out of energy because it isn't an engine or a fuel-powered force. It's the geometry of the universe itself. But once mass begins bending space-time, that curvature can reshape entire star systems. Now imagine traveling back in time about 4.6 billion years. Long before Earth existed, before oceans or continents formed, our solar system was nothing more than a vast drifting cloud of gas and dust. This enormous nebula floated quietly through space, cold, diffuse, and seemingly uneventful. But gravity was already beginning its slow and patient work. Tiny regions inside the cloud became slightly denser than the surrounding gas. Those denser pockets had just a bit more mass, and that meant just a bit more gravity. Like a snowball rolling downhill, they began pulling in more and more nearby material. The more matter they gathered, the stronger their gravitational pull became. Gradually, the entire cloud started collapsing inward. Gas and dust spiraled toward the center, forming a spinning disk around a growing young star. At the heart of this swirling structure, the newborn sun ignited, flooding the system with light and energy. Gravity had transformed a quiet cloud into a blazing star system. Meanwhile, inside the spinning disk, countless particles collided and stuck together. Dust grains became pebbles, pebbles became rocks, and rocks merged into enormous planetary embryos. Over millions of years, these growing bodies evolved into the planets we know today, including Earth. All of it driven by gravity steadily pulling matter inward. Without gravity constantly gathering material, this transformation would never have happened. The sun would not exist, and neither would the planets orbiting it. But gravity didn't just create worlds. It also shaped the conditions that allowed life to appear on at least one of them. On our planet, gravity feels so normal that it's easy to forget how extraordinary it really is. Every step we take, every drop of rain that falls, every ocean wave rising and crashing, all of it is quietly guided by the constant pull of Earth. Gravity is the silent force holding our entire world together. Without gravity, Earth's atmosphere would simply drift away into space. The air we breathe, oxygen, nitrogen, clouds, and water vapor, would slowly escape into the cosmic vacuum. Gravity acts like an invisible blanket, wrapping our planet in life-supporting gases. The same is true for our oceans. Billions of tons of water remain locked to the surface because gravity holds them down. Imagine the seas slowly lifting into space like mist from a boiling pot. Without gravity, Earth would become a dry, airless rock drifting around the sun. Gravity also stabilizes Earth's orbit around the sun. Our planet moves forward through space, while the sun's gravity continually pulls it inward. The result is a graceful balance, an orbit that repeats year after year. That steady motion creates the predictable rhythm of seasons. But Earth's story is only a tiny chapter in a much larger cosmic structure. Gravity doesn't just shape planets and solar systems. It organizes billions of stars into enormous spiraling islands of light, the galaxies that fill the universe. Now imagine zooming far beyond our solar system, past billions of stars, past enormous clouds of gas and dust, until an entire galaxy comes into view. One of these vast stellar cities is the Milky Way, and once again, gravity is the quiet force holding everything together. The Milky Way contains hundreds of billions of stars. Each one moves through space like a runner on an enormous cosmic track, yet none of them simply fly off into the darkness. Gravity binds them all into a slowly rotating spiral structure. Picture a gigantic whirlpool in space. Stars orbit the galactic center the way planets orbit the sun. Some take hundreds of millions of years to complete a single orbit. Gravity keeps the entire system stable across unimaginable distances. But something strange appears when astronomers measure these motions. Stars in the outer regions of galaxies move much faster than expected. According to the visible mass alone, those stars should escape the galaxy entirely. Yet somehow gravity continues holding everything together. This puzzling behavior led scientists to a mysterious discovery. There appears to be enormous amounts of unseen matter influencing galaxies. Astronomers call it dark matter because it cannot be directly observed. We only know it exists through the gravity it exerts. And if gravity can reveal invisible matter across entire galaxies, It raises an even deeper question about the universe itself. Where did this universal gravitational structure begin? To answer that, we must travel back to the earliest moments of cosmic history. To understand gravity's deepest role in the universe, we have to travel back almost 14 billion years, back to the moment when space itself began expanding in the event known as the Big Bang. At that time, the universe was incredibly hot, dense, and rapidly changing. But even in those first moments, gravity was already part of the cosmic story. In the earliest fractions of a second, matter and energy were spread almost perfectly evenly, but not quite perfectly. Tiny variations, barely detectable fluctuations in density, existed throughout the young universe. Those tiny differences would eventually become everything we see today. Wherever matter was slightly denser, gravity began pulling more material inward. That region would slowly grow heavier and stronger gravitationally. Over millions of years, gas and dark matter gathered into vast clumps. These clumps became the seeds of the first galaxies. Eventually, gravity pulled gas clouds tightly enough to ignite nuclear fusion. The first stars burst into existence, lighting up the darkness of the early cosmos. Those stars grouped into galaxies, and galaxies gathered into clusters and filaments. Gravity was sculpting the large-scale architecture of the universe. Today, when astronomers map the universe, they see enormous cosmic structures stretching across billions of light years. Galaxies form vast threads and clusters, almost like a gigantic cosmic spider web. Every strand of that web exists because gravity has been shaping the universe for billions of years. But the deeper wonder is that this same force connects everything, including us. After traveling across atoms, planets, stars, and galaxies, a quiet realization begins to emerge. Gravity is everywhere, yet it remains completely invisible. It has no color, no sound, no texture, and still it silently connects the entire universe. Every object with mass participates in this invisible network. The ground beneath your feet pulls gently on your body. Your body pulls back on the planet, even if the effect is tiny. And together, both of you are linked to the gravity of the sun. But the connection doesn't stop there. The sun itself is moving through the vast spiral of the Milky Way. That galaxy is pulled by neighboring galaxies, which themselves belong to massive clusters. Across unimaginable distances, gravity ties the cosmos together like threads in an enormous web. In a very real sense, every atom in your body participates in this universal interaction. The same gravitational laws shaping distant galaxies are acting on you right now. The universe is not made of isolated pieces drifting through emptiness. It is a connected system, quietly bound together by gravity. And that leads to one final thought worth holding on to. Gravity never sleeps, never stops, never turns off. It has been shaping the universe since the earliest cosmic moments. And even now, as you sit here watching this story unfold, you are part of that endless gravitational dance.